yet another video on our channel Euclid Mathematics. Today I am here one of the example from MHT CET previous year question paper. Examples and prepare for any competitive type of exam or to understand mathematical concept. First of all, we have to solve more and more example. This is the best way to understand any topic. So in my today's video, I will explain to you all one of the previous year question which is solely based on differential equation. It is a combination of a 2 to 3 topic like a differential equation, pair of straight line. So we have to use combined result from all the chapter in order to solve our today's examples. Okay. So now let's get start our today's example. Here is example 41. It says that if the line y which is equal to 4x minus 5 touches to the curve y square which is equal to ax cube plus b at the point 2, 3, then we want the value for 7a plus 2b. And option it is given first option 0, second option 1, third option minus 1, and fourth option 2. So we have to figure it out which one of the option is correct. Now here in our question, we have given equation of a line y which is equal to 4x minus 5, like y which is equal to mx plus c. Okay, so this is like a equation of a line and it touches to the curve, and curve it is also given y square which is equal to ax cube plus b. Okay, now at the point x is given 2, y is given 3, and then we want the value for 7a plus 2b. That means we want the value for a as well as we want the value for b. Then it is possible to find out 7a plus 2b. Now let's figure it out what is the value for a and b, and we will put that value here and we'll get the required answer from our option. Now let's get start our today's solution. So here in our question 41, we have given equation of a line and a curve along with the point 2, 3. Okay, now let's solve it further. So as we have in our example, equation of a line is in mx plus c form. Okay, and equation of curve is given ax cube plus b. So as we observe here, we have included a here and as well as b here. That means for finding value for a and b, it is easier to reduce the value for x and y. So if we take differentiation of ax, and it is possible to reduce the value for x here. Okay, it might be there other way also, but differentiation is easier way to reduce these variables like x and y. Okay, and we know that equation of a tangent or a slope of a tangent, we define it as the dy by dx. Okay, so by using this concept, it is easier to solve our today's example. Okay, now let's go for the solution here. So we know that slope intercept form. Okay, we have equation of a line mx plus c, then slope intercept form we write it as the, if a line has a slope m and its y intercept is a c, then equation of a line we write it as the y is equal to mx plus c. Okay, so it is easier to get the value for m and constant c from our equation of a line. Okay, now compare both of these. So we can see it is here. Now m is equal to 4 and c can be here as a minus 5. Okay, so c it is here minus 5 and m is here 4. This is just a comparison of a two equation, so we will get the easy value for m. Okay, that means slope of a line. So m, actually what is the value for m? M it is here slope of a line. Okay, and c is some particular constant. Now slope of a line y is equal to mx plus c, that means m is a 4. So I got the value for slope which is equal to mx plus m which is equal to 4. Okay, now y which is equal to fx is a continuous curve. Okay, so it is given y is equal to x cube plus b. So if we draw such a curve, we will get the continuous curve. Okay, because there is no gap in that curve. So it is a continuous curve at a point p x1 y1. So point is also given x1 y1 as a 2, 3. Okay, then slope of a tangent. So we have to apply slope of a tangent. As earlier I explained here, we have to apply differentiation in order to get rid of these x and y variables. Okay, so if we differentiate that, the value for it is getting reduced. Okay, because x cube and y square are given, so we have to remove that cube and square. Okay, so this is our first task. So only it is possible to extract a and b from our equation. Okay, now this is the easiest way. Okay, so for that extraction we need to apply application of a differential equation. Okay, so here we learn already in application of a differential equation, which is slope of a tangent, we can represent it as the dy by dx. Okay, So then dy by dx at a point x1 y1 0.23 is given, okay, and the slope of a curve, okay, so the curve it is also given y square is equal to x cube plus b, and the tangent to the curve y is equal to fx, it is given already at a point p, okay. So here at point x and y 2 3 given, then equation of a tangent. So try to remember the equation of a tangent from application of a differential equation, that we write it as the equation of a tangent y minus y1 which is equal to m into x minus x1, okay. So m here we have 4, okay, slope of here slope of a line which is m which is here 4, so I got the value for m here. X1 y1 means the 2 and 3, so we have to use the point 2 and 3 as a x1 y1 and substitute it here, okay. Then we will get the value for curve y square is equal to x cube plus b at the point continuous curve point p of 2 and 3, okay. Now here we have given equation of a curve already, okay. So what it is the equation of a curve y square which is equal to x cube plus b, it is already given equation of curve, okay, and at a point 2 3, so it has a curve point 2 3 also there given there, okay. That means we do not have to find the equation of curve, it is already there. So just go for finding the differentiation for a slope of a tangent, okay. So as I explained earlier, for finding the slope of a tangent, we used to find dy by dx, okay. So try to differentiate given curve, okay, at a point 2 3. At a point 2 3 means we have to select x as a 2 and y as a 3, okay. So go for the differentiation of our curve. So our curve is given y square is equal to x cube plus b, okay. Find out differentiation, so it is easier to get the reduced value for x square, x cube and y square, and substitute the value for 2 and 3 for x and y, okay. Now differentiate with respect to x our y equation in the form of y, okay. So with respect to x, a differentiation of y square, if we go through the constant term like this, it goes to 0, but we do not want it is 0 because we want the dy by dx, okay. That's why differentiate y square with a 2y with respect to y, okay. Y square with respect to y is a 2y, and differentiate y with respect to x again. We already learned it into the chain rule, okay. So if you don't know the chain rule and other differentiation topic, you may check it into my playlist. I already uploaded videos on these topics, okay. So y square we have to differentiate with respect to y, and y get differentiate with respect to x, okay. So y square with respect to y is a 2y, and y with respect to x is a dy by dx, okay. Now differentiation of ax cube with respect to x, which comes 3ax square and a plus b. So b is a constant here, okay. With respect to x, b is a constant, so the differentiation of a b, it goes to 0, okay. So 2i dy by dx which is equal to 3ax square. Now so we want the value for dy by dx, okay. So as it given in a slope of a tangent dy by dx, so we want the value for dy by dx for the particular point 2 3. So 2i it is multiplicand here, take it to the other side, so we will get the dy by dx which is equal to 3ax square upon 2y, okay. So substitute the value for x and y as x which is equal to 2 and y which is equal to 3. Then at a point 2 3, dy by dx at a point 2 3, so x is a 2, so 2 square it comes 4. A is a constant here, so a it will remain same, so a will remain same, 3 it remains same, and x square means a 2 square, it is a 4, and a 2 into y, so what is the value for y? 3. So 2 into y it comes 6. So go for finding the value. So 3 4s are 12a upon 6, that means 6 2s are 12a. So our dy by dx at a point 2 3, we got the value which is a 2a. And we know that slope of a tangent which is equal to dy by dx at a point x1 y1, okay. So x1 y1 it is a particular point which given in our example, okay. So x1 y1 it is already there, so we found the value for dy by dx at a point x1 y1, that is a dy by dx at a 2 3 which is equal to 2 times a. And slope of a tangent, we got the slope of a tangent already, it is here, which is a 4, okay. Slope of a tangent by using equation of a line, slope of a line, okay. Y is equal to mx plus c, so m it is coming from here, so the value for slope of a tangent it is a 4. Now substitute it is here, 4 which is equal to twice of a, then value for a it comes 2, okay. So I got the value for a is a 2. But in our example, we want the value for 7a plus 2b. That means still the value for b is remaining. So now let's get to find the value for value of b. Okay. So here at a point 2, 3, a is a 2 and the equation y square is equal to x cube plus b. So put a is a 2, then you will get the value for v. And we know that xy it is also there, okay? It is given in our example already. So x is a 2, y is a 3 and a is a 2, put it here. So y is a 3, that means y square, 3 square. A already there, a is a 2. We found earlier this value for a is a 2. X cube means 2 cube and plus b as it is. Okay, now find out the value for b from this equation. So 3 square it comes 9, 2 cube it is a 8, 2 the 16. So 9 which is equal to 16 plus b. Okay, 9 which is equal to 16 plus b. So take that 16 it is here. So 9 minus 16 which is equal to b. Then we got the value for b is a negative of 7. So a is already 2, b is a negative of 7. Then find out the value for 7a plus 2b, okay, which we want the value from our example. So 7 into a, 7 into 2 plus 2 into b. So 2 multiplied by negative of 7. So 7 2s are 14 plus 2 multiplied by negative of 7. So negative 14. So positive 14 plus negative 14. So the value it comes 0. So our required correct option is A. Okay, which is given in option A. The value for our example which is a 0. 7a plus 2b is a 0. Okay. Now see, it is a quite easy example. Nothing is difficult here on it. Okay, so we just have to apply a slope of a tangent from the differential equation and a slope of a equation of a line, okay, which is from pair of straight line. Only these two results we needed here. So see how easy that example and how easily these examples gives us a mark. Okay, just need to apply 2 to 3 results only. Okay, so I hope so you all have understood my today's lecture. So thank you everyone. Thank you for my lecture.